getting back into test 4. These are the 4 paper tests on College Board, and this is going to be part 3 of math. This is math module 1, and these are going to be some of the best problems here. So we got number 19 here. Again, my first inclination is I see a fraction over here, and I see an equal sign, so I want to cross multiply, right? So I go ahead, throw my 1 over here, and we cross multiply like this, and I get 14x is equal to 7, or rather 14y, right? 14y, and then times the square root of w plus 19. Now, before I go any further, let's kind of get their context right. They said which expresses w. So we are going to solve for w, but you're always going to cross multiply here. So now to get w, we want to get this alone. So I divide this by 14y, divide this by 14y, and our new equation should be x over y is equal to the square root of w plus 19. And again, it's kind of just chipping away at what's blocking our w, right? So now what's blocking our w is the square root. To do the opposite of a square root, you square it, right? So squaring a square root, we square everything over here. And remember, when you're squaring multiple things, whether they're dividing or multiplying, you square everything. So down below, I'll kind of show you what I mean. That should turn into x squared over y squared. So everything gets squared, right? And that should be just now a nice w plus 19. And our final answer, I'll try to squeeze it maybe at the bottom there. We just minus 19 from both sides, right? So I see x squared divided by, that's hard, y squared, there it is, minus 19. So that's the answer I should be looking for. I don't see it in A, I don't see it in B. So it looks like in C, all they did was they didn't distribute the squared, which is fine. I still know that's what I'm looking for. We have a squared x and a squared y minus 19. So really not too bad. That's just going to be practicing our algebra rules. Really, really good problem there. And then going down, I see number 20 here. Let's see what's going on. We have point 0 is in the center of a circle, so I'll draw it, right? We've got a circle here. And we have 0. The measure of arc RS, so let's go ahead and draw that, is 100 degrees. So maybe I'll say it's like a decent chunk. It'll be like that. So maybe that's R, that's S, and this kind of arch here, that is 100 degrees. Okay? And what is the measure in degrees of its associated angle ROS? Okay? So the wording can sound pretty tricky here, but we want to remember one thing, and that is that radians are equal to degrees in a way. So remember that radians are going to describe the distance around a circle, right? Like technically when you're giving circumference, of course you can give it in feet, you can give it in meters, but you can also give it in radians. You're also allowed to give radians in degrees, right? So these are kind of interchangeable. We have our translating units. Remember that for every pi radians, we have 180 degrees. So like these units are interchangeable. So they're actually describing this distance from R to S. Instead of feet, instead of meters, instead of radians, they're describing that distance in degrees. And then it's a little bit tricky, so they're asking for this angle. Well, angles we, again, can give in radians or degrees. It's nice they're asking for degrees instead of radians, so our answer actually is just also 100 degrees. Again, if we had to translate this into radians, well, there could be two ways. So again, we could use our little translator there. We want to set up a proportion. So I would say, okay, using this translator, we would match the degrees. The 180 degrees we know is equal to pi. And then we would say, okay, that's x radians that we don't know, right? So if I did this, if I cross multiplied, I would be able to solve for my x. I'd be able to figure out how many radians. It's just going to be 100 degrees because they're trying to be a little bit tricky. Jumping into number 21 here, it looks like this is going to be an exponent problem. I see expression 1 times expression 2 is equivalent to one expression. So they want us to go through this and combine all of our like terms. Before I can really start to multiply all this, like before I can do my 6 times this or anything in here times this, I probably want to get everything in exponent form. So we have a 6 over here, and then we have the 3 to the... So this is where we're converting our radical form into exponent form, right? So remember, off to the right here, I'll do a little roll. If I have the 5th root of 3 to the 5th, this is equivalent to, remember, you keep your numerator, so that stays as 5, and your denominator becomes what your root is. So this is actually equal to 3 to the 5/5, which just equals 3 to the 1, right? So as I'm going through this, try to keep that roll in mind. I'm just going to put the root as my denominator and keep the numerator as the numerator. So 6 times 3 to the 5/5 times x to the 45/5. Now let's use a different color for our second fraction. This is also going to be multiplied by 2 to the 8/8. And then times x to the 1/8. Right? Not too crazy. And as we go through for our solution, that's going to be 6 times 3, which is 18, times 2, right? Yeah, that's going to be 36. So I can get rid of all my numbers. I know those are going to equal up to 36. And then finally, we just have x to the 9 times x to the 1/8. And remember, that's going to be added together. So x to the 9 plus 1/8. And they want our exponent to be just a b. So I'm going to have to figure out a way to combine these, correct? So let's go ahead and maybe erase. Oh, we have space up here to the right. Okay. So if we want to combine 9/1 plus 1/8, we're going to have to get common denominators. So I just have to multiply this by 8, multiply this by 8, 5, 6, 7, 8, 72. So this is going to be equal to 72 plus 1, everything over 8 now because we have equal denominators. So 73/8, man. So we have 36x to the 73/8. Okay. And their final inquiry here is to add a and b together. That's great. I'm going to do it off to the right here. So we have 73/8 is b. And I'm going to add that to 36. And again, 36/1, we have to get to 8. So it's going to be times 8 and times 8. Don't have my calculator on me, so we're going to just throw that together real quick. So 6 times 8 is going to be 48. And then 3 times 8 is 240. And then where can I make space for this? I'm going to get rid of this stuff here. And that's going to become, so 288 plus 73. Wow, this is a mess of a problem. Plus 73, and that's going to be all over 8. And I think that's 291, 301, 361/8. And that is correct. So, wow, a lot going on in that problem. Yeah, that's a really good practice problem. Staying organized, making sure you know all your exponent roles. Yeah, excellent, excellent problem. Obviously a little bit easier with a calculator, but still fine. And yeah, jumping up from that, I don't know if we'll make it to 23. We'll try. Let's see how long 22 takes us. This is probably one of the better problems on the test. Very unique. But let's finish 22 first. So getting into 22, let's see what we got here. A right triangle has sides of these 3 lengths. Okay. So I guess the first thing I think of, and these are just important little kind of tools to build, is before I can even begin to label this, I would have to know which one's the biggest, right? So if we just try to think here, maybe that's like only 7, square root of that's going to be like 8-ish. So this is probably going to be our biggest number. So I think I'm comfortable in saying that's going to be square root of 80. But in your shoes, I would double check. You want to make sure, it doesn't matter which one my legs are, right? Because they're just the 2 smaller sides. I would figure out all 3 of these decimals and then plug in the largest one as my hypotenuse. Okay, so now that we have these labeled, what is the area of the triangle? So the reason why that's so important is when I'm doing area, remember the area of a triangle is base times height divided by 2. So we actually don't need our hypotenuse when we're finding the area of a triangle. So I want to make sure I label those right so I don't use that. So not going to be too bad. I just do 6 square root of 2 times 2 square root of 2, because that's my height, that's my base, and then I have to divide by 2, because normally just base times height would be of a rectangle, right? So we kind of multiply these individually, so that's going to get me 12. Square root of 2 times square root of 2 is actually going to get me 2, and then I still have to divide by 2 here, so those cancel out, and then I get 12. So B for this one. And I think that's it. I think I want to start with 23 kind of solo next time. But yeah, this is going to be part 3 of the of the paper test 4. Really good math section, and then from 23 here on, I'll probably make that my final one. Yeah, so these last 5 problems are going to be very, very excellent problems. Make sure to catch that video too.